Hello everyone, and welcome to the Mat 211 review of random variables, both discrete and continuous. So, two dice are rolled. Let X be the larger of the two results. Find the probability distribution of X, then draw a histogram of it. So, the easiest way to start this is to make a table of the results. Since we know that X is going to be discrete, and that's because an individual die has the values 1, 2, 3, 4, 5, and 6. So X is going to take a discrete value, and therefore drawing a table shouldn't be too hard. And a lot of times that is a little bit easier way to visualize our results. So let's go ahead and make ourselves a table. So we can have 1, 2, 3, 4, 5, and 6. Let's say that this is the first die, so whatever we deem as the first die. And we can have 1, 2, 3, 4, 5, and 6 for a second die. So now we want to think about what would happen if we rolled each of these combinations. Remember that X is the larger of the two results, so it's going to take the larger of the two values. So in the case that we have 1 and 1, well, they're the same, same amount, so it's going to be 1. Now in the case that we have 1 and 2, well, 2 is going to be the larger of the two values. This is also true if we have 2 and 2. So we'll have a 2 here. Or if we have 2 and 1, it would be 2. In the same way, we're going to have 3 up for our second die and 1 for our first value. Would have 3 would be the larger number. And 3 would be the larger number if we had 3 and 2. That would also be true if we had 1 and 3 and 1 and 2 in this direction. And then if we have both 3 and 3, well, they're the same value, so we'll have a 3. This will go on as well. So we'll have 4s down this column until we get to 4, which will also be a 4, but then we can move over and we'll have 4s along this way too. And then 5s along here, 5, 5, 5, 5, and 5, 5, 5, and 5, and then 5 for both 5 and 5. And then for 6 and 1, we'll have 6. 6 and 2 is also 6. 6 and 3, 6. 6 and 4 is 6. 6 and 5 is 6. And then the same goes for this column under 6 for the second die. So we have 6, 6, 6, 6, 6, and 6 if they're both 6s. So now let's think about drawing out our probability distribution. If we have X, then we want to know the probability that X takes on some value, so some little value. So imagine that this is a big X here and this is a little x here. So the little x's come from the random values inside this table. So if X takes one of these values, then we consider this to be our little x. So X equals little x would be equal to 1 if little x was 1. So the little x is the representation of the actual event happening versus the random variable, which can encompass many values, which would be the big X. So what we want to do is we want to think of all the different ways that this could happen. So we'd have 1, 2, 3, 4, 5, and 6. So this should actually be a little x here. Looks like a big X, but it's a little x. So maybe we'll make our little x's curly here to just distinguish them a little bit here. There we go. All right. So if we get a little x is equal to 1, then the probability that big X takes that little x value of 1, well, we need to know how many possible values we could have taken here, and then how many values of 1 there are. Now, we can see from this table just by multiplying that we have 6 rows and 6 columns, so we have 6 times 6 outcomes. We could also think of this as, for our first die, there are 6 possible outcomes, and then that would be times our second die has 6 possible outcomes, so that means we have 36 total outcomes that are possible. But some of these are repeats. But that's just all the different combinations of, the 2 different die that would produce these outcomes. So now we need to know how many of those 36 outcomes produce a 1 as our X value, our big X value. So we can see from the table that we have exactly 1 value within our table that is a 1. So our probability that big X is a 1 is going to be 1 over 36 because that's the total number of outcomes. Next, we can look at the probability that we get 2s. Well, again, we're going to have 36 total outcomes, but if we look at our table, there are 3 possible ways to get a 2. So this would be 3 over 36. Then if we look at the possible ways to get a 3, we notice that we have 5 possible ways to get a 3. So this would be 5 over 36. For our 4s, we have 7 possible ways to get a 4. So that would be 7 over 36. Then for our, we'll use a pink for this one. For our 5s, we've got 9 possible ways. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 over 36. And for our 6s, we'll make this one, I don't know, we'll make this one orange. For our 6s, we have 11 possible ways. So there's 11 different 6s in our table that come from 11 different combinations of our first die and our second die. So we have 11 over 36 for our probability that big X is equal to 6. So this is our probability distribution right here. Now we want to draw a histogram that represents that probability distribution. So let's erase our little notes here and we'll go ahead and draw our histogram. So we have 6 different values here that are possible, ranging from 1 over 36 to 11 over 36. So say this is 0, and this is going to be crudely drawn, so I apologize in advance. So this is going to be 1 over 36. This is going to be 3 over 36. This is going to be 5 over 36. This is going to be 7 over 36. 9 over 36. And 11 over 36. So these aren't exactly to scale, but hopefully you get the idea. Now we want to look at, so that's going to be our y-axis. That's going to represent our probabilities. Now we want to look at our values of big X. So big X equals little x here. And then we have the probability here, which we would want to write this probability here in, but I don't have room. So that's okay. So we're going to have a 1 here, a 2, a 3, a 4, a 5, and a 6. Now this is a histogram, so we're going to be using bars here. So histograms map values, so for instance a probability or something else like that, to individual values. So let's start with our 1. Well, we know that our 1 is going to go to 1 over 36. So there's our 1. Next, if we look at our probability that x is 2, we have 3 over 36. So we can just make another bar here like that. Color that guy in so it's obvious. Kind of poorly. Hopefully you can color better than this. Then let's look at our 3. So the probability that x is equal to 3 is 5 over 36. So that goes up here. Then the probability that x is equal to 4 is 7 over 36 from the table, from the probability distribution. So we'll just put another bar in there. Let's make that a little whiter. There we go. Color that guy in. Then the probability that x is equal to 5 is going to be 9 over 36. So there we go, something like that. And lastly, the probability that big X is equal to 6 is 11 over 36. So we'll give that a bar as well. There we go. So hopefully your drawing looks a little nicer than mine. But that is our histogram of our probability distribution of X. Big X, little x. So that's our answer. So this is our results that we used. This is the probability distribution of X, and then this is the histogram of that probability distribution. So before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Also, if you're looking for tutoring services for your specific course, we have the Tutor search tool, which you can find off of our main website here, or by going directly to the tool at this link, and that will allow you to find tutoring services for your specific course. So thanks so much, and have a great rest of your day.